Hello everyone, welcome to a new video on electromagnetic fields. In today's video, we are going to discuss about a new topic in electromagnetic waves. So in the previous two video series, we have discussed about electromagnetic waves. So in the first video, we discussed about electromagnetic wave equation, in which we discussed about electromagnetic wave equation for electric field as well as magnetic field. And then we discussed about wave parameters in the second video, wherein which the main parameters like wave velocity and propagation constant and then in characteristic impedance, these were discussed through this wave parameters video. And we also discussed about attenuation constant, propagation constant and all, phase constant, right? So in this video, we are going to discuss about power transmission in electromagnetic waves. How power transmission, energy transmission occurs in electromagnetic waves. So in this video journey, we are going to understand about electromagnetic power. How much power an electromagnetic wave has. That can be calculated, and with few real world applications we are going to discuss in this video. So this is the basic agenda. First, we are going to discuss about solar energy applications, where we are going to discuss about the solar light powers, and then the energy flow theory, and then we are going to connect it with real world some applications and a few problem solvement, and then finally we end up with a quick conceptual quiz. First, how does sunlight travels millions of miles through vacuum space? Have you ever imagined? Yes, it is because of the electromagnetic waves. So this is a prime example of electromagnetic energy transmission. The electromagnetic waves have power that travels through free space and through different mediums. It propagates through different mediums with the help of the power that each and every electromagnetic wave possesses. This sunlight is a form of electromagnetic radiations which carries bundles of energies that impact solar panels, converting light energy into electrical energy. Now, how can we mathematically tell the value for that electromagnetic power? That can be discussed through Poynting vector. Poynting vector, which is denoted by S, describes the directional energy flux of electromagnetic field. In simple, we can say it as the Poynting vector represents the power per unit area flowing through any surface. Mathematically, it can be expressed as S is equal to E cross H, which is nothing but E is the electric field and H is the magnetic field. We know that electric and magnetic field together compresses the electromagnetic wave. So by taking the product of these two fields, we can get the power of an electromagnetic wave. Its direction will indicate the propagation of this energy. So Poynting vector is a vector whose magnitude gives the power value and whose direction gives the direction of energy propagation. Now, how this electromagnetic power transmission is used in modern technologies? We can identify these with the help of these examples. Electromagnetic power flow is used in wireless power communications like radio waves, Wi-Fi, mobile networks and all. Then for satellite communications, GPS, internet, televisions, these electromagnetic power transmission is used. And then microwave ovens for heating food through molecular vibrations. Finally, we use solar power generations for converting sunlight into electricity. So we can say countless modern technologies wherein which this electromagnetic power transmission is taking place. So in simple, we can say as electromagnetic power transmission is an integral part of every modern technology that we are now witnessing and utilizing in our day-to-day life. How we can calculate the power through this plane? First, consider a plane with a given electric field amplitude and frequency propagating through defined area. So here the parameters that are defined are electric field, magnetic field, and we have the area of cross section. Our objective is to find the total power flowing through the plane, and we know the formula P is equal to integral S dA, where S is the pointing vector, and here the P is the power. Electromagnetic power is represented by P. And how we can get this power? We know pointing vector, which describes the electric and magnetic field. So by computing those two fields, we can get the power. So for computing those two fields, we can calculate pointing vector, which is S, with respect to the surface dA. So this calculation will yield the electromagnetic power in electromagnetic waves. So by calculating those S vector, we can easily find the electromagnetic power for electromagnetic waves. So through this we can, through this video, we have first understood what is electromagnetic power transmission and where is it is used, how we can calculate electromagnetic powers for different mediums through pointing vectors, and finally for plane, how we can calculate the electromagnetic power by integrating the pointing vector. So let's conclude. We have discussed about electromagnetic power transmission first with pointing vector S, whose direction gives the electric flux, and then the major elements for calculating the pointing vector is E and H, which is E is equal to electric field, the force on the charge, and H is the magnetic field, which is generated by the moving charges. By passing current, a magnetic field is produced, right? So that is what given here as generated by moving charges. And finally we are calculating the energy per unit volume. So this simple concept of electromagnetic power transmission is making the things more clear, and it helps us to understand how the electromagnetic power can be witnessed in each and every modern technologies. For further understanding and for further knowledge updations, you can go and visit electronics notes and power in electromagnetic waves link, and also RF power measurements, and of course our regular updations in MIT Open Courseware for electromagnetic energy and power transmission. So through this video we have discussed about electromagnetic power transmission and how we can compute it, where this electromagnetic power transmission can be witnessed with few real life applications. So with this we come to the end of this video. Thank you. Thanks for listening. Hopefully we'll meet in yet another video series of electromagnetic fields. Thank you.